Hello everyone, my name is Sheng from Group Cyberfiber. Today I'd like to talk about my network and communications individual report. So now I will start off with the overview of the project. For our project, it focuses on designing a scalable, secure network for UTMs, Faculty of Computing, Block N28B, supporting 4 IR advancements and a 15% growth in users. It features high-speed internet, VLAN segmentation, fiber optic backbone, next-gen firewalls, and Wi-Fi 6 to enhance research, education, and administration. Future improvements include AI-driven monitoring, cybersecurity training, and energy-efficient technologies for sustainability and security. Next, I would like to talk about my contribution to the group and project. As a team member of Cyberfiber, I play an active role in various aspects of the project. My primary contributions included Task 1 by designing the second floor layout using Cisco Packet Tracer, ensuring a logical and functional floor plan that met the project requirements. As for Task 2, I was required to conduct a feasibility study evaluating project from technical, operational, and economic perspectives to ensure scalability and cost efficiency. As for Task 3, I was responsible for maintaining minute meetings, ensuring proper documentation of discussions and decisions. Then, I was responsible for determining number of connections, patch cores, and switch ports required and measure cable lengths for work areas considering walls and corners in Task 4. Following up, I was responsible for assigning usable IP addresses to devices in each room and reserve IP addresses for future growth, ensuring an efficient IP addressing scheme for scalability and performance in Task 5. Lastly, I was responsible for writing the conclusion in Task 6, discussing achievements, strengths, weaknesses, and suggestions for the project improvement. I was also responsible for the minute meetings for Task 3 and Task 4. Next, I'd like to talk about the contributions of other team members by task. For T-Sun-Jie, he was responsible for designing the second floor layout using Magic Plan for Task 1. As for Task 2, he was responsible for designing 5 questions in Part 2 regarding network security, maintenance, and scalability. As for Task 3, he was responsible for deciding on LAN devices and network hardware. Following up, he researched and identified cable types and media such as twisted pair, fiber optics, or wireless based on capabilities and limitations, and meshed cable lengths with chosen technology at Task 4. As for Task 5, he was responsible for analyzing the network address and device needs, and also calculated total device counts per room and estimated future expansion. Lastly, for Task 6, he wrote a concise one-page abstract summarizing the project and results, organized and compiled the table of contents and table of figures for easy navigation. He was also responsible for minute meetings in Task 1. Next, I would like to talk about Beatrice N. Davis' contribution in the project. For Task 1, she was responsible for designing the first floor layout using Cisco Packet Tracer. Then, she was also responsible for designing 5 questions in Part 1 regarding recommended networking devices and estimated bandwidth in Task 2. Then, she was responsible for researching network devices to be used in Task 3. She was also responsible for identifying work areas on the floor plan in Task 4. After that, she was also responsible for recording the mini meetings for Task 5. Lastly, she was also responsible for collecting and summarizing results from Task 1 to 5 into a coherent section, including reflections and corrections made as a group. She also listed all team members and their roles in completing the project, referring to minute meetings for details. She was also responsible for the minute meetings in Task 1 and Task 5. Following up, I would like to talk about Abhilashini's contributions in the project. For Task 1, she was responsible for designing first floor layout using Magic Plan. As for Task 2, she was responsible for designing 5 questions in Part 3 regarding network planning and implementation. Then, she was responsible for providing detailed information on selected devices in Task 3. After that, she was responsible for planning and documented backbone or vertical cabling and distribution or horizontal cabling connections in Task 4, including confirmed interconnections for all network devices and areas. After that, she was responsible for performing subnetting based on device counts in Task 5, ensuring efficient allocation of subnets without overlapping. Lastly, she was responsible for writing about the project aims, scopes, objectives, and assumptions in Task 6, providing a summary of the client's initial situation and the problem being addressed. She was also responsible for the minute meetings in Task 1 and Task 2. Next, I would like to talk about how we work as a group. Through the project, our group functioned effectively through a structured and organized approach. We held meetings to discuss progress, assign new tasks, and troubleshoot any issues that arose. Each team member was assigned specific responsibilities based on their strengths and expertise, ensuring efficient work distribution. Communication was the key to our success as we utilized tools like WhatsApp and Google Drive to share files, track deadlines, and maintain transparency in our work. Regular peer reviews were also conducted to maintain quality, accuracy, and consistency across all sections of the project. This collaborative strategy allowed us to stay aligned with project objectives and address challenges promptly. Next, I'd like to talk about the lessons learned from the project, starting off by the lessons learned from the group work. Through this project, I realized the importance of effective communications in teamwork. Regular discussions ensured that everyone was aware of their responsibilities and deadlines, leading to smooth project execution. I also learned the significance of time management as dividing tasks among members helped us to stay on schedule and complete deliverables on time. Additionally, problem solving became crucial as I encountered obstacles such as balancing cost and performance. Through research and discussion, I found viable solutions that met both project constraints and expectations. As for the lessons learned from the project, this project enhanced my technical knowledge, particularly in network infrastructure design, IP addressing, and feasibility analysis. It provided me with the opportunity to apply theoretical concepts to a real-world scenario, strengthening my ability to analyze and implement networking solutions effectively. Furthermore, I managed to gain insights into the importance of scalability in network planning. Designing the infrastructure to accommodate future growth ensures long-term sustainability, making it a valuable lesson for future projects. Now I would like to continue with the reflection on task performed. For task 1, I managed to improve my ability to create structured network layout using Syswa Packet Tracer. As for task 2, I managed to deepen my understanding of feasibility assessments, particularly in balancing economic and technical factors. Following up, I managed to enhance my skills in documenting key discussions and decisions to ensure team accountability in task 3. Following up, I managed to gain practical experience in determining network requirements, including calculating number of connections, patch cores and switch cores, as well as measuring cable lengths while considering physical barriers for precise infrastructure planning in task 4. After that, I managed to develop hands-on experience with subnetting and IP addressing, which is essential in network engineering through task 5. Lastly, I managed to reinforce the importance of structuring reports professionally and ensuring cohesive project documentation in task 6. Next, I would like to talk about the comments and suggestions on the project, starting off with comments. At first, the project consists of a comprehensive network design in which the project effectively incorporates scalability, security, and performance, as well as the use of fiber optic backbone connections and VLAN segmentation enhances efficiency. Besides, the project has a strong feasibility analysis in which considerations of technical, operational, and economic feasibility show a well-thought-out approach. The inclusion of cost-benefit analysis also ensures budget optimization. In addition, the project also consists of an efficient IP addressing scheme in which the subnetting and addressing strategy is well-structured, considering both current and future expansion needs. Lastly, there's also security considerations in which implementation of firewalls, encryptions, and network monitoring tools improves cybersecurity. Next, I'd like to talk about the suggestions on the project. For the project, it should have cost efficiency considerations in which high-end networking devices should improve security and performance but increase overall cost. Therefore, exploring cost-effective alternatives without sacrificing essential features will also improve the budget management. In addition, the project should have energy efficiency and sustainability. High-performance networking devices require significant power. Therefore, integrating energy-efficient hardware and smart power management solutions would reduce energy consumption. Lastly, the project should have future scalability and upgrades in which Wi-Fi 6 implementation ensures strong connectivity, but planning for Wi-Fi 7 and future advancements will improve long-term network sustainability. Lastly, I would like to talk about the conclusion. In conclusion, the network design for faculty and computing block N28B is a well-executed project that delivers a scalable, high-performance, and secure network infrastructure. By integrating fiber optic backbone connections, VLAN segmentation, and next-generation firewalls, the design ensures efficiency, reliability, and future growth. Despite challenges like cost restraints, energy consumptions, and complex subnetting, the team effectively balanced performance, security, and budget considerations. The structured IP addressing scheme and 15% growth capacity makes the network adaptable for future needs. Moving forward, AI-driven monitoring, cyber security training, and energy-efficient solutions could further optimize performance. Overall, this project has been a valuable hands-on experience in network engineering and IT infrastructure management. Thank you.